Let's take a look at a mirrorball rotator, and this is arguably one of the earliest disco lighting effects. And it's very simple. It's just a synchronous geared motor, and it's designed to rotate a polystyrene molder, either polystyrene or fiberglass balls covered in pieces of mirror. And when you project a fairly focused beam at it, it shatters the light everywhere. It's the classic ballroom effect. And the reason I'm featuring this in the video is because it's a great way to get off the shelf a synchronous motor that has a very slow rotational speed. Typically, the speed of these will be 1 revolution per minute. Let's plug this in and demonstrate that. Let's also plug it in and analyse it in the hoppy meter, which does indeed, as someone recently said, remind me of the display from the DeLorean. So it's rotating now, but you can't really see it's rotating other than the fact it's going to drag the chain shortly. Power consumption is just over 4 watts. Power factor is extremely good. It always is with these little synchronous motors at about 0.86 watts. And the current consumption is about 19 milliamps. Very, very low power, but extremely strong. It's rotating very slowly, and as you probably saw, it was rotating anti-clockwise. If I turn it off and on again, still rotating anti-clockwise, off and on again. Just keep turning it off and on until it does. No, it's not going to do it. There it goes. It is rotating clockwise. Now, you see, these things don't have a particular direction. You do get versions with a direction, but most of them are just for cheapness. They'll just pick a random direction at power up, and they'll go in that direction. And if you stall them, they'll go in the other direction automatically. It's just the nature of the motors. So if I open this up now, inside, and many of you who have used old-fashioned disco lighting effects, or indeed anything with a geared synchronous motor in it, will recognise this because it's a very, very standard form factor for these type of motors. The only thing it tends to change is the shape of the shaft, which is a bit annoying because I've got one here that I'll be taking to bits shortly. Let's bring it into shot, this grubby one that I'd really like an identical shaft to that, but can't find it. I may have to grind one. So now I've undone, oh actually let's take the chain off, that'd be a good idea. Incidentally, these don't need to just rotate mirror balls. You can use them to rotate anything. If you had a display in a shop, if you even wanted to hang a fairly lightweight bicycle or something from them, as long as the combined weight of what you're hanging is less than 2 kilograms for these particular motors, then it will handle it fine. That's really just probably the safe loading of the actual bearing itself before it pulls the shaft out. But you do get stronger motors for the bigger balls. You also get motors that run at different speeds. This one is called FX Lab G007NV, but you also get the 007NT, which rotates at twice the speed, 2 RPM. Now, if you've seen these motors in the past, if you've seen them in devices, you'll immediately recognise this because it's an absolutely standard form. This large diameter shaft with the hole through it, they're very useful. They're sometimes used, the higher speed ones are sometimes used with motors, should I say with mirrors, and they'll just put a bolt through this hole so it actually deliberately stalls at the end of travel, and by pulsing it on and off, the mirror will pan backwards and forwards. They use them in many inventive ways in disco lights. What does it say about this one? It says 50-60 Hz. It says, well, let's zoom in a bit. 50 or 60 Hz, and the speed will change. At 50 Hz, this rotates at 1 RPM. At 60 Hz, it would be a slightly faster speed. It would be 120 RPM. Oh no, it wouldn't be 120 RPM. It would be faster at 1.2 RPM, might be closer, I think. But you either get them marked CW for clockwise, CCW for counterclockwise, or in this case both, because it doesn't have a direction. It will just randomly go in the direction that it chooses at power up. So you can buy these quite cheaply as just motors on eBay because they're designed for various other applications. They're often sold from Chinese sellers for use in microwaves for rotating the turntable, usually a direct drive. And also you can get them in this form, which I believe is for an incubator. It rotates once every, it's 2.5 or 3 RPM, and it nudges, I think it nudges the eggs and moves them slightly for some reason. I'm not really into chickens, so I wouldn't know why they'd nudge the eggs like that to move them. This one is notably, incidentally, a bit thinner. Oh, it's not that much thinner, it just feels strangely thinner. Is it a different diameter? slightly smaller diameter, slightly smaller thickness. I don't know how much that will be the motor and how much it will be the gearing. This one has deliberately got quite heavy gearing in it because it is designed for the heavy load of, for a heavy downward load of the mirror ball or whatever you're hanging from it, whether it be a display, a tyre could be rotating in a shop, display window, anything. You can just suspend a lot of stuff from them. They're very useful. Anyway, before I start running off a huge list of things you might suspend from the ceiling and have rotating, let's take a look at this one, because that'll let us see what's actually inside them. And this one is gubbed. This one is wrecked. This is out a Miko DD8L dehumidifier, a desiccant dehumidifier. And this was the motor that was used to rotate the desiccant drum. And because it's had very high load against it, much higher than it's really designed to take, this sort of side load, it's physically ground the bearing sleeve there. It's an odd shape now, and it's also ground into the shaft. It really has just been mincing and grinding away in there to the point that the inside is just a mixture of grease and iron filings. So here's the inside. We have quite heavy gearing, and they seem to some of these seem to use a standard form of plates with the pins, and you get different combinations of gears. Other ones have a lot more of these pins depending on the sort of gearing ratio. In the middle is the rotor, which is just a permanent magnet rotor. It's also worth mentioning, this one has a little stem kicking out the side. I'm trying to see, where is it? This has a mechanism that rotates underneath it, and it very simply slips backwards and forwards, but as it slips, if it's going the wrong direction, it will actually ride onto this and it will physically stop this rotating by that little collar, and then it will kick off in the other direction. So if it's going in the right direction, it will wind that sort of out the way, but if it's going the wrong direction, it will wind in until it physically stops it and it will kick it off in the right direction. This one didn't. This one used to actually just go in a random direction, mainly because it was just filling up with gunk and everything was just sticking up and stopping working. The motor itself, let's see if we can get this out with a pair of long-nosed pliers. Okay, there's one part of it. This is the one plate, one side of the magnetic field that's used to provide the rotation with little fingers, the stator. Let's see if we can get this out. This could be tricky, I'm not sure how well stuck in this is. There we go. It's ultra simple. It's a bobbin with the wire just wound round it, so that either side of it is going alternately north and south magnetic fields when the mains AC supply is applied to it. And another thing that's interesting about this is if you pull this little clip off, this just physically unplugs from an improvised connector of pressed metal. And it means that depending on the type of lead you want, depending on the manufacturer's type of motor, they can physically just plug on the lead after perhaps threading it through the casing, and then put this clip on and it just locks that in place, and that's the connection. So it's just for maximum manufacturing versatility. But this alternates positive in the north and south magnetic fields. And the stator poles, and here's something quite interesting, they're not evenly spaced. This goes in from one side, and say for instance the magnetic field was in one direction, these poles would be north, and they're interleaved like that, they're sort of interwoven like that. So these would be north and these would be south, and by alternating them it provides a rotating magnetic field. I'm just going to zoom back out here because it's going to be cluttered in here now. And the magnetic rotor then rotates between those magnetic fields because it's got fixed poles in it. Now, I wonder how many poles this has got on it. I've got a magnet here. Let's see if I can actually detect 1, 2, 3. I'm going to lose track here. 4, 5. Is that 5 poles it had? 1, 2, 3, 4. I think it was 5. I'm losing track here. Hold on, I'm just going to pause a moment and just work this out properly. Right, okay, I was talking crap. It has 4 pairs of poles, look of it around it. And that kind of matches up with the poles here, but I wonder why these are, 2 of these are much bigger, and I get the feeling, and these are skewed off to the side slightly, and I get the feeling that may be to provide, so it doesn't get stuck in a single position, it provides a sort of phase rotation, so to speak, because otherwise it could just vibrate backwards and forwards. You can feel it stepping as you rotate it around. It's not as clear as it would normally be because this is covered in manky grease and it's just making it stick. But that is the principle of these. It's ultra simple. I suppose ultimately if you had a weird motor and the windings had failed in some way and it wasn't burned, I suppose that technically speaking, as long as you took note of the gears and you opened the motor carefully, you could probably rewind it. Never tried that. But the winding would be so simple because all you need is a core to actually put it on, rotate that while you've fed the wire on. Or I suppose ultimately if you had a perfect motor that was for a higher voltage like this one, the 240 volt, you could theoretically rewind it for a lower voltage. But that does involve, in the case of the classic way these are constructed, these are sort of crimped in. It would involve bending that out to get it open and also making a good note of where all the cogwheels went and the order of which they sit in, because otherwise you might end up having a bit of a puzzle trying to get the cogwheels in the right order. So yeah, quite interesting. Quite nice to see inside one of these. And these, as I say, that it's worth, these don't cost a lot because they're one of the most mass-produced and simplest things. It's a plastic case. It used to be metal, but now it's plastic. But it's got the earth onto it, though. But it's one of the easiest ways to get a good low-speed mains voltage synchronous motor, and it's got loads of other uses. One other thing that's quite interesting, you can also get what are called chandelier rotators. Much harder to get, much more expensive. They're kind of specialist. But they're like a mirrorball rotator, except they have slip rings and they've got a disc with a sort of power outlet hanging on it. And it means you can plug a chandelier into it. And in a showroom, you can have the whole chandelier all lit up and rotating. But it could probably have other uses for signage as well. I think it was the British Turntable Company or Bristol Turntable that used to actually make stuff like that. I don't know if they still do. I know they're still about in one of those forms. But anyway, interesting stuff. These motors really are very simple and super reliable.